In order to empirically design an expert progressive, I like to gather information in office at the initial fitting. First, I'll measure the patient's manifest refraction with add power to determine their best corrected visual acuity and the amount of astigmatism. Next, I'll use a corneal topographer to measure the patient's corneal measurements and toricity. After the topography, I'll place my patient in the slit lamp and I'll evaluate their lid positioning, the palpebral fissure width, the lower lid height, and the pupil size. At this point, I'll also note the patient's lid tonicity and its ability to support a gas-permeable lens that will rest on the lower lid. When designing the Expert Progressive GP multifocal lenses, one of the measurements that we'll take into account is the corneal size, also known as the horizontal visible iris diameter. When measuring this, we often use a PD rule, or many times a topographer measures the corneal size. For patients who have large corneas, I would say over 12 or 12.2 millimeters in overall diameter, I would choose a lens that's slightly larger, like 9.5 or 10.0, to accommodate for the patient's larger cornea to add to the lens stability. If a patient has a small cornea, such as 11.6 or smaller, I might choose a lens that's quite a bit smaller, like 8.5 or 9.0. By matching the lens diameter to the corneal size, this provides for the lens to fit well so that the optics are optimally positioned in the patient's different line of sight. While it is not necessary to have a corneal topographer, it is certainly helpful in designing the patient's lens. Not only does it give another measurement of pupil size and horizontal visible iris diameter, it also helps in the lens back surface design. If a patient has astigmatism that extends limbus to limbus of a moderate amount, I may order a toric lens design to assist in lens stability. This lens is very customizable for pupil size, so it's very important that you take a good look at them prior to ordering the lens. It's important to note whether a patient has small, average, or large pupils, because the pupil size can impact the lens optics, distance, intermediate, and near. When looking at lid position, one of the first things I measure is the palpebral fissure width, or the distance between the upper eyelid and the lower eyelid. Knowing this measurement helps in selecting lens overall diameter, and if the palpebral fissure is very small, I may order a smaller lens, or if it's very wide, I'll order a larger lens. The palpebral fissure width can also affect the overall lens stability and the lens centration. After measuring palpebral fissure width, I'll then note the position of the lower eyelid. I describe the lower eyelid in three ways. It's either positioned high, which is above the lower limbus, average, which is positioned at the lower limbus, or low, which means the lower eyelid is positioned below the lower limbus. Having knowledge of where the lower eyelid is placed not only impacts the lens overall diameter, but also the height of the intermediate and near segment powers.